So now we are ready to see something about midpoint circle drawing algorithm, right? So here actually, suppose we have a circle. My circles are not round, huh? So suppose we have a circle. So we understand that it can be divided into quadrants, like here. Now we can understand one more thing, that it can also be divided into octants. Okay, octants can also be symmetric, right? We have to keep this thing in our mind, that symmetric property is very helpful. Octant means 45 degree, right? 45 degree. So suppose this is a point which will give you the octant. So this arc here will be symmetric to this particular arc. Symmetric means it looks similar, some values will change. What are the values that will change? At here the value, if at all it is xy, then here it will be yx. This is called symmetry. Very simple. Similarly here what will be the value? This was xy, this was yx, so this will be just minus sign, minus of this y comma x. Okay, here it was the value of y, na? So where it is written like this, it is something, the value for this particular axis first, and then on this vertical axis, right? So for horizontal axis negative sign, and for vertical axis positive sign, right? What will be here? Here you will have definitely minus x and y. Okay. Similarly here it will be, both of them are minus, minus x minus y. Then here minus y minus x. In this quadrant it will be y and minus x. Here it is x y. Okay, here it will be plus x and minus y. Okay, so just you have to find out the pixel values in one octant, and using this value you can easily find the values of other octants. Okay, so now let us start this midpoint circle drawing algorithm, where we will understand that we will have to find only the pixels of one octant. Although if we don't want to do that, we can find the values of others also, no problem. But this is the simplest way, that is what we should follow, because although in midpoint circle algorithm we are decreasing the number of operations, we have to perform certain calculations to find the pixels, right? Earlier we had to use either the square root operation or trigonometric operation. Now we don't want to do that. We will try to make it a arithmetic operation. Just means arithmetic means only integer operation, but still it is an operation. When only changing the signs and places will give you the exact coordinates, then why do you want to perform the calculations, right? So this is what we will do. We will try to find the values of an octant, and using this we will retrieve all other pixel values. Okay, one more thing that we have to consider, definitely whenever we are trying to print a circle, in that case there will be certain something we call it as center. So it is xc yc, right? And there will be a radius will be suppose r, right? Now one thing that we have to do here is, we have to bring this center to 0 0. Okay, and using this 0 0 we will try to find the octant, and later on find the circle, and then in all the pixels we will add the value of xc and yc so that it will be transformed to its original place. Okay. So what we are doing, we are calculating the pixels, keeping the center as 0 0, and then we are transforming it to its original place. For transforming, what we have to do, we have just to add the coordinate value xc yc in the actual coordinate values. Okay, we will retrieve here. For now we have to understand this thing only. Let us go for understanding midpoint circle algorithm. One thing that we can understand here is, for finding something in one octant, what we have to do, we have to just move on increasing the value of x, right, and finding the values of y. That was actually what we were doing till date, but now we have to find all the pixels here, right. We will come to it. For now, let us start with one function. Let me call this function of xy. Okay, let me write function fc of xy is what? X square plus y square minus r square. Okay, you can understand this is the same Pythagoras theorem which says x square plus y square is equal to r square. Okay, so I am making this r square on this side. So in ideal case, means if that particular pixel is on boundary, is on the circumference, then what will be the condition? This particular thing, x square plus y square is equal to r square, right. In that case, x square plus I square minus r square should lead to 0. Suppose, let me write it again. If your point xy is on boundary, then what happens? Your fxy fc, okay, fc xy will be equal to 0. Okay. So if the point is in the interior of the circle, for any point you are trying to calculate this fcy, and that point is inside the circle, then this will be some negative value. Okay. If it is outside the circle, in that case this will be positive value, and if it is on the circle, definitely it is 0, right. Let me write it in this way, that your fc xy will be what it will be? It will be less than 0, negative, in case your xy is inside the boundary, inside the boundary. It is equal to 0 if xy is on the boundary. Okay, and it is greater than 0 if xy is outside the boundary. So how are you going to proceed? Okay, what we have seen is this fxy is less than 0, which means negative when the pixel is inside, equal to 0 and greater than 0 in these cases. So suppose what happens, let us use these squares here. So here you can say, suppose you have just plotted a pixel xk, yk, right? Let me take this pixel. This is your xk, yk. This was your xk and this was your yk. Okay. Now the next thing is, according to your circle, whatever your circle is going, it may be your circle would be going something, I don't know, like this. Anyway, what you have to do, you have to choose a midpoint here. Okay. You have to understand, we are going according to the midpoint. So now you have to guess what will be the next pixel, either this or this, right? We can understand either this or this. Anyway, the xk will increase, right, with 1 pixel. So either it will be, where should we write, xk plus 1 comma yk, or it will be xk plus 1 comma yk. Okay, it is decreasing here, yk minus 1. Okay. So these two are the possibilities. We have just to decide what it will be, right? So let our decision parameter be something like pk, as it was in Bresnan's algorithm. Here I am taking pk. Okay, pk. What is it? Your function based on x is increasing, and let me take y at the midpoint. Y is yk minus half. Okay, I am taking like this. I am decreasing half. Okay, now we will see this value if it is near to 0 or not. Okay, midpoint. So what it will be look like? It will look like the value of this square plus this square minus r square, right? Xk plus 1 square plus yk minus half square minus r square, right? So now this pk, using this value, you already have this xk value. We will see how to do this recursive also, but for now, xk, so for pk we have got this thing, right? So if this pk is less than 0, we will understand that this midpoint is where? Midpoint is inside, right? If it is greater than 0, we will see the understand that it is, this midpoint is outside the circle. If at all it is on the midpoint is on the circumference, then it is 0, pk is 0. In that case, we understand that the point is on the circumference, right, on the boundary. So we will check the value of pk, whether it is less than 0, equal to 0 or greater than 0, right? So what we are doing, pk is less than 0. We understand that midpoint is inside the circle. So if at all midpoint is inside the circle, then in that case what we are going to do, we will keep the yk itself. We understand that since the midpoint is inside the circle, it means that yk is something which should be plotted. If at all midpoint is outside the circle or on the boundary, we plot the yk minus 1. That is the thing. Now using this pk, is it possible, as in Bresnan's we have seen, we use this pk to find the pk plus 1 also, right? So let me try to derive that particular expression. pk plus 1, what it will be? Function of your xk plus 1, whatever it was, plus 1, okay, and yk plus 1 minus half. Is it? So this is what we got, na? Fk was fk plus 1 and yk minus half. So if it is k plus 1, so xk plus 1 plus 1 and yk plus 1 and half. Okay. So if you try to derive it a little, what we can write about it? We can write a square of this thing plus a square of this thing minus r square, right? Let us try to write it. X a k plus 1 plus 1, okay, xk plus 1 can also be written as xk plus 1. What? Let me write it like xk plus 1, okay, this was xk plus 1, this thing, and plus 1, right? So a square of this, then plus a square of this thing, yk plus 1 minus half. I am not replacing yk plus 1 with any other thing because it is a variable. Sometimes it is yk and sometimes it is yk minus 1, right? So yk plus 1 minus half square minus r square. This is something you got for pk plus 1. Now, if you will try to derive it further, what you will get is sometimes you will say what was pk? Xk plus 1 square plus yk minus half square minus r square. So this particular thing altogether can be written as pk, right? Xk plus 1 square will come, yk plus 1 minus half square will come, and minus r will come. It is coming here, right? And apart from that, you will also get 2 into xk plus 1, 2 into this thing, plus 1 square will be there. So in last, let me write it plus. Before that, let me write something about this. What it will be? It will be yk plus 1 square minus yk square minus yk plus 1 minus yk. Okay, these two things can be kept like this, okay, plus 1. Okay, so this is something that you will get for pk plus 1. Try to derive it and find it whether you are getting this thing or not. Here a few things that you are able to understand, that what is yk plus 1? Yk plus 1 will be either, this yk plus 1 will be either yk or yk minus 1, right? Whether the value of pk was positive or negative kind of thing, right? So now incrementally you want to get this pk plus 1 on the basis of these values of pk and xk and these values, right? So okay, so a few things you have to understand. If pk is negative, what is happening? Your pk plus 1, what it will be? Pk plus 1 will be, suppose pk was negative. In that case, since pk was negative, so this pk plus 1 was pk itself, right? So pk square minus pk square will be 0 and pk minus pk will be 0. So you will get something like I should say 2xk plus 1, sorry, 2xk plus 1, let me write it like this, 2xk plus 1 plus 1, this one, okay, if at all this is yk minus 1, in that case what you will get? Okay, let me write it nicely, that if this is 2xk plus 1 plus 1, if pk was negative. Okay, and this is what it will be, 2xk plus 1 plus 1 is definitely here, and minus, from here you will get minus 2yk plus 1. Okay, if at all it is otherwise, let me write it otherwise. So this is what you get here. Now there is 2xk plus 1, 2yk plus 1. This can be done incrementally, right? You will not have to calculate that much. Let me write it here. 2xk plus 1, what it will be? This will be 2xk plus 2, right? 2yk plus 1, what it will be? It will be 2yk definitely minus 2, right? So in the start what will happen? In the start you will keep the position, in the start with position, start with position 0 comma r. Okay, so at this position what will be the values of these two terms? At the starting position the value of these two terms will be 2xk plus 1 is 0 and 2r, right? Okay. Okay. Now this is the story of a start, है ना? After it has started, recursively in each iteration we will try to find out the value of these values, right? How we will find? Just by addition of 2, and yeah, right? Here you will add 2 and here you will subtract 2, right? So in this way in each iteration we will be able to find this value. Now, so initially what will be the decision parameter? Suppose the starting point was x naught y naught, है ना, which is 0 comma r. So for this you are trying to find out P0. What will be P0? The function of, it will be suppose 0 plus 1, right? So 1 and r minus half. So r minus half, let me write like this, r minus half, and if you will calculate it, what will you get? Definitely 1 square is 1 plus r minus half square and minus r square, right? So from here you are getting plus r square minus r square, definitely 2r and half. You will calculate all these things and in last you will get 5 by 4 minus r. Okay, so this is your P naught. So here you can also understand that if the radius r is specified as an integer, we can round this value to something like 1 minus r, right. Let me write it like this. Since this is a fraction, right, and all the computation will be in integer. So, if you are trying to round it down, so since it is 5 by 4, okay, you are rounding it to 1 minus r. Okay. So, this is what you get. You have initially your P naught. Now, successively you will try to calculate P1, P2, and accordingly you will judge what will be the value of y, right. So, as we did in Brasnam's line drawing algorithm, here again in midpoint method, what we are doing, we will try to calculate the pixel positions along the circumference of the circle using integer additions. Addition and subtraction also. Here you will have to add in x and subtract in y, right. So, what are you doing here? Basically, you are trying to start with 0 comma r, which means this position, right. This is where x is 0 and y is r, and from here you will try to calculate till where? Till 45 degree, right. How you will get this as 45 degree? At 45 degree, what will happen? At 45 degree, the value of x is equal to value of y, right. Here x is equal to y. So, here you have started with x is equal to 0, and you will go till this position where x is equal to y. Okay, this is your y, this is x. Okay. So, the value of x becomes equal to y. So, till this position you keep on finding the pixel values. Okay. So, what you are doing, you are just taking the 0 comma r, and in each iteration you are incrementing the value of x and decreasing, or either you are decreasing or keeping the same value of y depending on the value of your pk. So, in each iteration you will try to find P1, P2 and so on, and try to find the next pixel, right. So, so let me show you the example here. Before example, let me show you the algorithm, right. So, this is your midpoint circle drawing algorithm, right. So, here you can see what you have to do. You will input the radius, definitely you need the radius and the center. Okay. Then you will start to find the first point. Okay. So, first point is your 0 comma r. Then you will calculate the position 5 by 4 minus r. You can keep it as 1 minus r also, let it be. So, this is your decision parameter P naught. Now, this P naught, whether it is less than 0 or not, accordingly you have to take decisions, no problem. Means okay, you will have to go for pk. This is the P naught which will be used later, right. So, at each xk position, starting at k is equal to 0, perform the following test. If pk is less than 0, the next point along the circle centered on 0 0, okay, is xk plus 1 yk, and pk plus 1 is something like this. Okay, pk plus 2k plus 1 plus 1, if at all it is less than 0. If at all it is greater than or equal to 0, in that case you will go for other option where y will decrease, and the pk plus 1 will be this value. So, here you will see the value of pk as well as 2x k plus 1 and 2y k plus 1. In the last case, it was the pk itself, and the y value was not included, right. Simple, very simple. You can calculate the value of 2k plus 1 as by addition of 2 and 2yk plus 1 by subtraction of 2. So, using this thing at each xk, right. So, this is a loop here. Here you will try to find out all the values until you get to x is equal to y, right. Okay. Also, okay, you have to determine the symmetry points, other 7 coordinates. Like here you are trying to find some value, since you are doing in this coordinate, here in this octet. So you are trying to find these values. So using these values you can easily find the values in other octants as well, right? So find those things. Now move each calculated pixel position xy onto the circular path centered on xc, yc. How you will do that? This was what you did on 0, 0, right? So now you will add xc and yc to all the pixel positions. The pixel positions are x, y. So in each x you are adding xc and each y you are adding yc. So it will be transformed to your original position. Okay, this will be your xc, yc. So this is something you did for a pixel. Now step 3 to 5 for all the pixels in between x is greater than equal to y, until x is greater than equal to y. So what they are saying, that this is a loop here. You will have to repeat these things for how many times? Until x is equal to y. Okay, either x is equal to y or greater than y. If it becomes equal to y, then you have to stop the algorithm. So this was your midpoint circle drawing algorithm. Now we can think of an example of midpoint circle drawing algorithm. Let us see this example in the next video.